So the first question asks us to draw a graph that represents the meaning of the term f prime of x times delta x. So we can draw a graph, and it's probably useful to draw the coordinate axes, and we can draw any kind of a curve we want. Okay, draw this curve. And we want to show this at a point. So let's just pick a point on the curve. I'm going to pick this point here. Okay, now, what does this point represent? It represents the x-coordinate x and the y-coordinate, which is f of x. So this is the point x, f of x. We want a delta x. So let's have some kind of a delta x, probably starting at x. We're going to move some distance, delta x, in some direction. And we're going to end up at the point x plus delta x. So we've got a delta x in here, and it's related to the x. Now we want an f prime of x. How are we going to represent f prime of x? What is the role of f prime of x on this graph? Or what aspect of this graph represents f prime of x? Well, we should be very clear by now that f prime of x is going to represent the slope of the graph when the x-coordinate is whatever it happens to be. Now, here the x-coordinate happens to be x, so f prime of x is going to be the slope of this graph at this point. So we sketch a tangent line. And when I say the slope of the graph, I'm really talking about the slope of the tangent line. So here we have the tangent line with a slope f prime of x. So right there's our tangent line with that slope, and it's tangent at the point x, f of x. Now, what do we mean by f prime of x times delta x? Well, we can draw a triangle. Let's go ahead and project this x plus delta x up here more or less along a straight line. So we could put delta x here, and then if we extend on up to here, we have a point on our tangent line, and delta x is the run, f prime of x is the slope of this tangent line, so that the rise is equal to what? Well, rise divided by run equals slope, so the rise divided by delta x equals f prime of x, and if you don't have that in your head, you should write it down, so that since the rise divided by delta x equals f prime of x, the rise has to equal f prime of x multiplied by delta x. So that f prime of x times delta x represents the change in the y value along the tangent line. Now I paused for a minute to extend my y-axis up a little higher so that I can project across here. So this is the y-coordinate here. Well, the distance here is equal to the rise, so that this distance again is f prime of x delta x. Hopefully that's legible. So that the coordinate here is going to be f of x plus f prime of x delta x. Okay, this distance here is not equal to the actual change in the value of the function. the change in the value of the function is just from here to here. I'm going to go off camera and sketch something in here. The actual change in the function is the change from here to here on the actual graph of the function, on the actual curve. And so this we're going to represent as delta y. Okay, delta y, the actual change in the y value. Or we could write that delta f also if we wanted to. Now, we see that delta y and f prime of x delta x are not the same. But if we used a smaller delta x, the delta y and the f prime of x delta x would be much closer. So, for example, if the curve looks like this, we've got this point here, we've got the tangent line. If we use a smaller delta x, and I'm going to go off camera again for a second, and I'm going to kind of redraw this with a couple of different colors because I think it's going to be important to see the difference. Okay, I've drawn a curve and a tangent line here, and in light blue I've drawn a triangle between this point of the curve and this point of the curve. And the change in y, or the change in the value of the function between this point and this point, is clearly the rise of this triangle. Now, I haven't drawn the hypotenuse, and that would get a little bit cluttered, but you understand I could have drawn the hypotenuse. But I have the rise here, I have the run here, which is implicitly delta x, just as it is up here. Now, if I use the f prime of x, in other words, if I follow the tangent line, the rise between this point and this point is going to be f prime of x times delta x. So I'm going to write that sort of parallel here, and here's my f prime of x delta x. Okay, now that's just essentially the same picture I have above. Now if I use a smaller delta x, and let me find a color that contrasts a little better here. Okay, now, if I use a smaller delta x, and instead of this blue triangle, I'm going to use red. So we see that I have a delta y here, and if I go up to the point on the tangent line, it's a little bit higher. And I don't know how well this is going to show up, but we have this distance based on, again, the f prime of x delta x for the new delta x. Now I hope it's clear that this f prime of x delta x that we calculate here is almost twice our delta y. So this doesn't make a very good approximation to our delta y. Over here, the delta y that we get is this little red segment here, and the f prime of x delta x is this orange segment, which is longer, but it's not nearly twice as long. It's maybe 25% longer. It's not more like 75% longer. So we have a much better approximation in the sense of having a smaller percent error if we use a smaller delta x. And it should be clear that the smaller the delta x we use, the closer this curve is going to hug the tangent line, and the less error we're going to get using f prime of x delta x to predict our delta y, which is what we're going to end up doing. So, think about this a little bit. We're going to go ahead and apply these ideas to a number of expressions and a couple of situations.